Okay, so today I'm going to cover completing the square. Okay. Some of you may remember this from Math 1000. If not, then we'll go over it today. If you do remember it, it'll just be a review. Okay, so first, before we get into completing the square, we're going to do a quick review of the square root property. Okay, so square root property just says that if x squared equals some number c, then the square root of x squared and the square root of c, or I guess you could say plus or minus the square root of c, so x is just equal to plus or minus the square root of c. Okay. Which is basically just a long way of saying if you do something to one side, you want to do it to the other. Thank you. Okay, so for example, say if you wanted to solve x squared minus 12 equals 0. Okay, so x squared minus 12 equals 0. If you just add 12 to both sides, negative 12 plus 12 cancels out. So you have x squared equals 12. So now we just square root both sides. So square root of x squared equals plus or minus square root of 12. The square and the square root will cancel each other out. So you're left with x equals, and with plus or minus square root of 12, we know that square root of 12, you can rewrite that as square root of 4 times 3. And whenever you have the factor or two factors under square root, you can separate them. So you have square root of 4 times square root of 3. And square root of 4, we know that's just 2 square root of 3. Okay, so we can rewrite this as plus or minus 2 square root of 3. All right, so any questions on this one? All right, oops, this down here. All right, so let's say for the next example, we want to use the square root property. To solve, say x minus 1 squared equals 16. Okay, so once again, you just square root both sides. Move that over a little bit. Okay, so your square and your square root are going to cancel each other out. So you just have x minus 1 equal square root of 16 is positive or negative 4. Okay. Now you just solve for x by just adding 1 to both sides. So x equals 1 plus or minus 4. Okay, so that just translates to x equals 1 plus 4 or x equals 1 minus 4. And then you just solve both of them for x. Okay, so x equals 5 or x equals negative 3. Okay. If you plug them both into your original equation, you see they both are true. They're both true. Okay, so if you plug in 5 minus 1 is 4. Oh, wrong one. 5 minus 1 is 4. 4 squared is 16. Plug in negative 3. Negative 3 minus 1 is negative 4. Negative 4 squared is 16. Okay, so they both work out. All right. So any questions on this one? All right. Okay, so let's do one more quick example, and then we'll go into completing the square. Whoops. Okay, so let's say if we wanted to solve for x, 3x plus 8 squared minus 6 equals 0. Okay. Now with this one, you wouldn't just jump in and square root both sides. You can only square root both sides once you've isolated your squared term. So that means you'd have to get this term by itself. So before you square root, okay, so that means if we have 3x plus 8 squared minus 6 equals 0, we just have to add 6 to both sides. Okay, these two cancel each other out. So we're left with 3x plus 8 squared equals 6. Okay, so now that we have this isolated, now we can square root both sides. Okay, so any questions on that step so far? All right. So now if we square root both sides, square root of 3x plus 8 squared, the square root of 6. Here the square and the square root just cancel each other out. So you have 3x plus 8 equals plus or minus square root of 6. That should have been a plus or minus there. So now we just subtract 8 from both sides. These two cancel out. Do that up a little bit. So we have 3x equals negative 8 plus or minus square root of 6. Now we just divide every term by 3. Move that up here. Anything divided by itself is just 1. So you have x equals negative 8. Clean that up a little bit. Negative 8 over 3 plus or minus square root of 6 over 3. Or if you want to just separate it, you can have negative 8 over 3 plus square root of 6 over 3. Or x equals negative 8 over 3 minus square root of 6 over 3. Or if you wanted to, you could just have negative 8 plus 6 over 1 square root of 3. So there's a couple of ways you can write it, but all of them are correct. All right. So any questions on this so far? All right. I'll leave that up for a couple more seconds. All right. Okay, so now we can transition from there to completing the square. Okay, so now for completing the square, we have to remember our perfect square trinomials that we did. And I believe it's 1,000. But here's a quick review. If you remember, a plus b squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. Okay. So quick example of that would be x squared plus 10x plus 25. Okay, so you can actually rewrite that as x plus 5 squared. Okay, simply because this is your, if you let your a equals x, since 25 is 5 squared, make your b equals 5, then that means that middle term has to equal 2 times a times b. Since it does, you have 2 times x times 5. Give you your 10x, you can just rewrite it that way. All right. Okay. Now, in order to complete the square, you have to add, well, I guess if it's an equation, you have to add and subtract. But you have to add b divided by 2 squared. And that gets your binomial, I guess you could say your variable binomial, and turns it into a perfect square trinomial. Okay. So to complete the square, let's say if you have x squared plus bx. You just add and subtract I guess you could say the square of 1/2 the coefficient of x. Okay. So in other words, for x squared plus bx, you just want to add or add and subtract b divided by 2a squared. Oh. Check these. Yep, the coefficient of x. Okay. But in this case, since a is equal to 1, you can just say b divided by 2. Okay, so for example, excuse me. Let's say if we wanted to complete the square of x squared plus 14x. So remember, for your x squared plus 14x, clean that up a little. In this case, your a is equal to 1. Okay. Because remember, you're looking at the form ax squared plus bx plus c. So in this case, in front of your x squared, your a is equal to 1. And your b is equal to 14. Okay, so in order to complete the square, b divided by 2a squared is going to equal 14 divided by 2 times 1 squared, which is just 7 squared. Now, before you apply the squared, you want to remember that value. Okay, so you just have 49. So you have x squared, move that up a little bit, plus 14x plus 49 minus 49. So basically you just added 0. Okay. Now these three terms now just became a perfect square trinomial. And the reason I say remember this number is because these three terms just now turn into x plus 7 squared. So whatever value you have here before you apply the squared, that's what that's going to become. So you have x plus 7 squared minus 49. And for some problems, they may just want the x plus 7 squared. Kind of depends on the individual problem. All right. So any questions on that one? All right. All right. Okay, so let's say, for example, wanted to complete the square for x squared plus 7 over 3x. All right, so for this one, same process, but the next step, I just kind of tweak it to make it a little bit easier. Okay, so for this one, a is equal to 1, but b is equal to 7 over 3. Okay. So for your completing the square, once again, it's b divided by 2a squared. Okay. So in this case, we have, at least for fractions, let's say 7 over 3 divided by 2 times 1 is just 2 squared. Okay, so what I normally do is I just rewrite it. 7 over 3 divided by 2 squared. Or instead of 2, you can write 2 over 1. Okay, so now we have the division of fractions. So the steps for dividing fractions, if you remember, is you write down the first fraction. Your division changes to multiplication. Then you just flip the second one. Okay. So you end up with 7 over 6 squared. And remember, before you apply that squared, you want to remember that value there, which is, so you have 49 over 36 for your completing the square value. So that's what you're going to add and subtract to this. Move that down a little bit. There we go. Okay, so that means we have x squared plus 7 over 3x plus 49 over 36 minus 49 over 36. Okay, so we just created a perfect square trinomial. And these are the ones where it comes in handy to remember these, because instead of trying to figure out what the perfect square is, you already know what it is. So this just becomes x plus 7 over 6 squared.
I got a question.
Sure.
In the middle, like 7 over 3x, so it should be like, the b should be 7 over 3.
Mm-hmm.
But how does 7 over 6 the whole square? It's not it doesn't look like b.
Oh, for your b value, yep, you have your 7 over 3. And remember, for your completing the square, it's your b divided by 2 times a. So here, it's 7 over 3 divided by 2 times 1, which is just 2. So all I did was get this and rewrote it like that. 7 over 3 divided by 2. So then once you have two fractions, you write down the first fraction. Your division problem, or division sign, turns into multiplication, and then you flip the second one. So once you flip the 2 over 1, it just became 1/2. So once you have just multiplying, you can just multiply your fractions right across. So you have 7 times 1 and 3 times 2. Does that make sense? Okay. All right, so for this one, it ends up being x plus 7 over 6 squared minus 49 over 36. Like I said, some, I'm not sure, I have to double check, but some of them, when they say completing the square, they may just want you to put that, but they'll usually let you know. Okay, so any questions on this one? All right. Okay, everybody's still writing. Looks like everyone got that one. Okay, so now that was just using completing the square for individual expressions. Now we're going to solve problems using completing the square. Okay, so you have steps for, instead of completing the square, you'll just see me write CTS. For ax squared plus bx plus c equals 0. Okay, for step 1, if your a is equal to 1, you just go right to step 2. If a is equal to 1, go to step 2. Okay, so if a is not equal to 1, you want to factor from the first two terms, whatever that value is, to get the a to equal 1 next to the x squared. So if the coefficient of x squared is not 1, oh, I meant divide, said factor. Divide every term by whatever that a is. To make the coefficient equal 1. Okay, so if you had 7x squared here, you divide everything by 7. If you had 12x squared, you divide everything by 12. Whatever it is to get that x squared by itself. Okay, so you want to isolate all variable terms. Uh-oh. Clean that up a little bit. To one side. And non-variable terms to the other. Of the equal sign. Clean that up some. Okay, so really all that means is that you're going to subtract whatever that C value is from both sides. Okay, so your third step, you're going to use completing the square to add b divided by, I guess you could say 2 squared, because remember we already made sure our a was equal to 1 from step 1. To both sides of the equal sign. Okay. Now if you wanted to for this step, you could just add and subtract your b divided by 2a, but then you'll wind up just adding it to the other side anyway. So this kind of eliminates a step a little bit. Okay, so this creates a perfect square trinomial. Okay, and then 4, you're going to solve using the square root property that we did at the beginning. So you're going to solve for the variable. I would say x, but sometimes it's different. Using the square root property. Okay. Now in this one, you want to remember the plus and minus sign. It's really, really easy to forget. Okay, and last, you just want to check your answers. In the original equation. Right. Let's do a quick couple of examples. Okay, so let's say if we wanted to solve x squared minus 8x minus 5 equals 0 by completing the square. Okay. Let me just rewrite it real quick. And remember, it's in the form ax squared plus bx plus c equals 0. Okay. So remember, for your first step, your a is equal to 1. So when your a is equal to 1, you can go right to step 2. But we know your a is equal to 1, your b is equal to -8, and your c is equal to -8.